بالعلم بل بالأدب تنال أعلى الرتب عش حياة العلماء وقرأ صنوف الكتب ودم على تواضع لا تفتخر بالنسب كفاك أن تخرج من
Bismillah ar-Rahman ar-Rahim. This is Dr. Shadi Masadeh from CNS Department and Faculty of Information Technology in Applied Science University. Today we are going to talk about the ARB and reverse ARB, Address Resolution Protocol and Reverse Address Resolution Protocol. And we are discuss the main objective of this lecture, the differentiate between static mapping and dynamic mapping, and understanding the need of address resolution protocol, then understanding the cases in which ARB is used, the understanding component and interactions in the ARB packages, and finally understand the need for reverse ARB. Mapping techniques. We have two types of mapping techniques, static mapping and dynamic mapping. The delivery of packet to a host or a router requires two levels of addressing, logical and physical. We need to be able to map the logical address to its corresponding physical address and vice versa, static mapping and dynamic mapping. The static mapping here create a table that associate a logical address with a physical address. The table is stored in each machine on the network. And the limitations of static mapping is a machine could change its NIC, it means network interface card. And in some LANs, the physical addresses change every time the computer is turned on. And also a mobile computer can move from one physical network to another. And finally, a static mapping table must be updated periodically. The dynamic mapping, each time a machine knows one of the two addresses, logical or physical address, it can use a protocol to find the other one. Two protocols have been designed to perform dynamic mapping: Address Resolution Protocol (ARP) and Reverse Address Resolution Protocol. ARP and Reverse Address Resolution Protocol use unicast and broadcast physical addresses. This figure shows the mapping technique of ARB and reverse ARB as we mentioned before. ARB. Here we explain in details ARB address resolution protocol. To find the physical address of next hop on the network, an ARB query packet is sent. The packet includes the physical address and IP addresses of the sender and the IP addresses of the receiver. The query is broadcast over the network. Every host or router on the network receives the ARB query packet, but only the attended recipient recognizes its IP address and sends back an ARB response packet. The response packet contains the recipient IP and physical address. ARP operation. In this figure, the system on the left, it means system A, has a packet that needs to be delivered to another system B with IP address 141.23.56.23. System A needs to pass the packets to its data link layer for the actual delivery, but it doesn't know the physical address of the recipient. It uses the services of ARP by asking the ARP protocol to send a broadcast, as we can see here. It uses the service of ARP asking ARP protocol to send a broadcast request packet to ask for physical address of a system with IP address of 141.23.56.23. This packet is received by every system on the physical network, but only system B will answer it, as shown in this figure. System B send an ARP reply packets that includes its physical address. Now system A can send all the packets it has for this destination using the physical address it received. ARP packet. This figure shows ARP packets. The fields are as follows. Hardware type. This is a 60-bit field defining the type of the network on which ARP is running. Each LAN has been assigned an integer based on its type. For example, Ethernet is given the type 1. ARP can be used on the physical network. And protocol type. This is a 60-bit field. Define the protocol. For example, the value of this field for the IP version 4 protocol is 0800 based on 16. ARP can be used with any higher level protocol. Hardware length. This is an 80-bit field defining the length of the physical address in byte. For example, for Ethernet the value is 6. A protocol length. This is an 80-bit field defining the length of the logical address in the byte. For example, for the IP version 4 protocol the value is 4. Operations. This is a 60-bit. This is a 16-bit field defining the type of packets. Two packets types are defined. ARP request number 1 and ARP reply number 2. Sender hardware addresses. This is a variable length field define the physical address of the sender. For example, the Ethernet, this field is 6 byte long. Sender protocol address. This is a variable length field defines the logical. For example, IP address of the sender for the IP address protocol. This field is 4 byte long. Target hardware address. This is a variable length field defines the physical address of the target. For example, for Ethernet, this field is 60 byte or 6 byte long for an ARP request message. This field is all zeros because the sender does not know the physical address of the target. Target protocol address. This is a variable length field defining the logical, for example IP, address of the target for the IP version 4 protocol. This field is 4 bytes long. In this figure, we show the encapsulations of ARP packet. An ARP packet is encapsulated directly into a data link layer frame. For example, in this figure, ARP packet is encapsulated in an Ethernet frame. Note that the type field indicates that the data carried by the frame is an ARP packet. We conclude that an ARP address resolution protocol request is a broadcast, and address resolution protocol ARP reply is unicast. Rarp, reverse address resolution protocol. Rarp finds the logical address for a machine that only knows it's a physical address. A reverse address resolution protocol request is created and broadcast on the local network reverse address resolution protocol client, and another machine on the local network that knows all the IP addresses will respond with reverse address resolution protocol reply. We can conclude that the reverse address resolution protocol request packets are broadcast and reply packets are unicast. In this figure, address resolution protocol operations, we have two sides here, or two hosts here, host and reverse address resolution protocol server. Host A, for example, send a request message for all hosts in the same network or in the same link. The request is a broadcasting. The message is, my physical address is A4 6E A5 57 A2 36. I am looking for my IP addresses. Then in the another side, reverse address resolution protocol server send a reply message. Reply is a unicast. The message is, your IP address is 141.14.56.21. This figure shows the reverse address resolution protocol packet. This figure is the same figure of address resolution protocol, but different in two fields. Field number 1, sender protocol address, for example 4 bytes for IP address, and it's not filled for the request. And the field number 2 is here in target protocol address, for example 4 bytes for IP address, it's not filled for the request. And this figure shows encapsulations of reverse address resolution protocol packet, and it contains a primable, and SFD is the size is 8 bytes, and the destination address, the size is 6 bytes. Source address, the size is 6 bytes, and the type 2 bytes. Finally, CRC, the size of 4 bytes.